Let's let x be equal to omega raised to the kth power. Then we can rewrite the expression as x squared minus 2x plus 2. Finding the roots of this quadratic using the quadratic formula, we get 1 plus or minus I, which means we can write this as the product of factors x minus 1 plus I and x minus 1 minus I. When we resubstitute for omega, this becomes omega to the k minus 1 plus I and omega to the k minus 1 minus I. So this is our product rewritten in terms of these factors. And because multiplication is commutative and associative, we can choose to multiply these first factors first, and then we'll next multiply all of these second factors. Let's take a look at the product of this expression. We'll let y be equal to 1 plus I and rewrite it. I'm going to reverse the order of these terms as y minus omega to the k power. We have 13 factors in our product multiplied by -1, which means we're going to have an extra negative outside of this product. We'll expand this product, leaving the negative on the outside. This is for k equals 0, k equals 1, and so on. If we multiply these factors, we see that we get a degree 13 polynomial in y, whose roots are the 13th roots of unity. And this is because we're given in the problem statement that omega is not 1. If you're unfamiliar with the roots of unity, there's a great explanation in the AOPS textbook Pre-Calculus in section 7.3. It steps you through the whole thing. As the 13 roots of unity, these are the solutions to y to the 13 minus 1. We'll substitute back in 1 plus I for y. Similarly, with our second factor, using the same steps, we can rewrite this as the negative of 1 minus I to the 13 minus 1. We're interested in the product of these two factors. Negative times negative is positive. Since we're taking a power of a complex number, I'd like to rewrite 1 plus I and 1 minus I in their exponential forms. Here's 1 plus I. Its angle is pi over 4 and its magnitude is root 2. And over here is 1 minus I. So I can rewrite this as root 2 times e to the pi over 4 times I. This is all raised to the 13th power, and then we subtract 1. Over here we have the same magnitude, root 2, e, and then it's negative pi over 4 because we're going clockwise, raised to the 13th power minus 1. This is much easier to take a power of. Root 2 to the 13th power is 64 root 2, and then we just multiply this exponent by 13, so we get 13 pi over 4 times I, and the same thing over here. Let's figure out where 13 pi over 4 is. It's down over here in the third quadrant, the same as 5 pi over 4. So negative 13 pi over 4 is up here at 3 pi over 4. So I'll rewrite these. Now let's see what are their rectangular coordinates. This is our angle, 5 pi over 4. This is our magnitude, 64 root 2. So our rectangular coordinates are negative 64 and negative 64i. And then we still subtract 1. At 3 pi over 4, we're up here, and the imaginary part is positive 64i. And we'll simplify this to negative 65 minus 64i and negative 65 plus 64i. This is difference of squares, so we can write this as the square of 65 plus the square of 64. This is 8321, which is 321 in mod 1000. If you'd like me to solve any other math contest problems, please leave them in the comments.